Have you ever wondered about the history of the Manhattan Project? Let's embark on a journey back to the early 40s, to the birth of a project that would forever change the course of history. The Manhattan Project, an ambitious endeavor of science, politics, and war, was born out of necessity. World War II was underway, and the United States had just entered the fray. The stakes were high, and the race for atomic power was on. The project was initiated by a letter from Albert Einstein and his colleague Leo Szilard. This now infamous Einstein-Szilard letter, penned in 1939, warned of the potential for the creation of an atomic bomb and the threat of Nazi Germany developing such a weapon first. The letter found its way to President Franklin D. Roosevelt, who recognized the potential risks and rewards. The world's most powerful weapon could be in the hands of the enemy, or it could be a tool for ending the war swiftly and decisively. The decision was made, and the Manhattan Project was born. The project was named for the Manhattan Engineer District of the U.S. Army Corps of Engineers, where much of the early research was conducted. However, the operation would soon expand across the country, involving the brightest minds of the time, including Robert Oppenheimer and Enrico Fermi. These scientists, many of them refugees from fascist regimes in Europe, were united by a common goal: to harness the power of the atom before their enemies could. They worked in secret, under the pressure of time and the weight of the world's fate. Each discovery, each experiment, brought them one step closer to an uncertain future. And so, with a letter from Einstein, the blessing of Roosevelt, and the collective might of some of the world's greatest scientific minds, the Manhattan Project was set into motion. It was an endeavor shrouded in secrecy, driven by fear and necessity, and powered by the raw potential of atomic energy. Thus, the stage was set for one of the most ambitious scientific endeavors in history. Imagine living in a city that doesn't officially exist. Now let's weave through the shroud of secrecy that veiled the Manhattan Project. The clandestine nature of the project birthed the creation of covert cities like Los Alamos in New Mexico, Oak Ridge in Tennessee, and Hanford in Washington. These enigmatic metropolises, swathed in enigma, were the beating heart of the project, hidden away from prying eyes and curious minds. Los Alamos, the city on the hill, was the nucleus of it all, the secret city where the brightest minds of the era converged to unlock the power of the atom. Here, the world's leading physicists, engineers, and mathematicians were sequestered away, working ceaselessly on the world's deadliest weapon. Meanwhile, Oak Ridge, the city of hidden hills, was the hush-hush hub of uranium enrichment. Thousands of workers toiled day and night, unaware of the gravity of the work they were undertaking. The city was a hive of activity, buzzing with the hum of the calutrons that were instrumental to the project. On the other side of the country, Hanford was the clandestine city producing plutonium, the fuel for the bomb. The city, built in a desert, was a testament to the sheer scale and audacity of the Manhattan Project. The monumental scale of the project was staggering indeed. It was not just about building a bomb. It was about constructing entire cities, maintaining an air of secrecy, and managing a workforce of over 130,000 people, most of whom were oblivious to the true nature of their work. But such was the nature of the Manhattan Project. Secrecy was its lifeblood. The walls of these secret cities echoed with whispers that were drowned in the hum of machinery and the clatter of scientific progress. The next act was about to begin, and it would forever change the course of history. The secret cities were buzzing with activity, and the world outside remained oblivious. Behind the secrecy and the politics, the heart of the Manhattan Project lay in scientific innovation. The project was a marvel of ingenuity in the midst of a global conflict. Two distinct types of bombs emerged from the labs and workshops, Little Boy and Fat Man, each designed with different principles and mechanisms. Little Boy, the leaner of the two, was a gun-type fission bomb. It worked on the principle of shooting a subcritical piece of uranium-235 into another subcritical mass. The resulting supercritical mass initiated a nuclear chain reaction. Imagine striking a match and setting off a fireworks display. But instead of fire and light, you get a release of energy on an atomic scale. Fat Man, on the other hand, was an implosion-type nuclear weapon. This type of bomb used plutonium-239, a man-made isotope. Rather than shooting one piece of fissile material into another, Fat Man worked by compressing a subcritical sphere of plutonium-239 using conventional explosives. The pressure caused the plutonium to reach a critical mass, triggering a nuclear chain reaction. It was like squeezing a balloon so tight that it pops, releasing an unimaginable amount of energy in the process. But these weren't just oversized grenades. The science behind these bombs involved intricate calculations and precise engineering. The researchers had to calculate the exact amount of fissile material needed to achieve a critical mass. Too little, and the bomb would fizzle. Too much, and it could pre-detonate. They had to engineer the explosives to provide uniform compression in Fat Man. They had to ensure the gun-type mechanism in Little Boy fired at the right speed. The scientific innovation of the Manhattan Project went beyond creating a weapon. It opened up a new field of study, nuclear physics. It pushed the boundaries of what was known about the atom and unlocked the secrets of nuclear energy. But, as the scientists worked tirelessly, a question loomed in their minds. The science was sound, but would it work in practice? July 16, 1945 marked a turning point in human history. This was the day when the world's first atomic bomb, a creation born out of the Manhattan Project, was successfully detonated in a test known as the Trinity test. A new era of warfare and power dynamics had dawned, but it came with a devastating cost. The Trinity test took place in the Jornada del Muerto desert of New Mexico. As the mushroom cloud unfurled, the immense power of the atomic bomb became evident. The blast was equivalent to an explosion of about 20,000 tons of TNT, creating a crater over 1,000 feet wide and obliterating all within its reach. The shockwaves were felt over 100 miles away. Yet, the true horror of the atomic bomb was yet to be fully realized. Less than a month after the Trinity test, 2 more atomic bombs, Little Boy and Fat Man, were dropped on the Japanese cities of Hiroshima and Nagasaki, respectively. The destruction was beyond comprehension. In an instant, buildings were flattened and lives were obliterated. In Hiroshima, the bomb killed an estimated 140,000 people, either instantly or from the lingering effects of radiation. 3 days later, in Nagasaki, 70,000 people met a similar fate. The scenes of devastation were a stark reminder of the destructive power humanity now wielded. Survivors, known as hibakusha, carried physical and emotional scars for the rest of their lives. Many suffered from acute symptoms like burns and radiation sickness, while others would later develop cancers and other long-term health issues. The impact on these cities and their people was catastrophic, forever marking them with the haunting legacy of the atomic bomb. The bombings effectively ended World War II, but they also ushered in the atomic age. The world had suddenly been thrust into a new era, one where the potential for destruction on an unprecedented scale was a very real possibility. The world had witnessed a power like no other, and the consequences were unimaginable. The Manhattan Project didn't just end with the bombings of Japan. Its legacy reverberates through the annals of history, marking the dawn of a new era, the nuclear age. The world had witnessed a power so immense, so devastating, that it would forever alter the course of human conflict and diplomacy. In the immediate aftermath, the United States emerged as a global superpower. The world had seen the destructive potential of nuclear weaponry, and the balance of power had shifted dramatically. This shift sparked an era of tension and competition known as the Cold War, with nations racing to develop their own nuclear arsenals. While the Manhattan Project spawned the nuclear arms race, it also spurred advancements in peaceful nuclear technology. The same principles that unleashed atomic destruction also gave rise to nuclear power, providing a new source of energy that could power cities without the harmful emissions of fossil fuels. Yet the project also left behind a darker legacy. The bombings of Hiroshima and Nagasaki raised profound ethical and moral questions. Was the use of such a devastating weapon justified even in the face of a seemingly endless war? These questions continue to fuel debates and shape policies today as nations grapple with the moral implications of nuclear weapons. Furthermore, the project's legacy extends to the scientists who were part of it. Many were plagued by guilt and regret, their names forever associated with a weapon of mass destruction. Yet their work also pushed the boundaries of human knowledge, opening the door to a deeper understanding of the universe. It also brought about a new era of government-funded research, setting a precedent for the large-scale scientific endeavors that would follow, such as the space race and the Human Genome Project. The Manhattan Project left an indelible mark on history, shaping the world as we know it today. It was a testament to human ingenuity and a stark reminder of the immense power and responsibility that comes with scientific discovery. If you enjoyed this history of the Manhattan Project, please consider subscribing for more 10-minute timelines.